Okay, so we're going to do a quick review of right triangle trigonometric ratios here, and a couple of things. So this video in particular is kind of geared towards a pre-calculus course. So we're about to start talking about things like the unit circle and periodic functions, which are based on trigonometry terms, but use a little bit of a different notation and actually a different measuring system for angles altogether. But we'll get into that in a later video. First thing we want to talk about though is this Greek symbol theta. Okay, this is how we notate angles for triangles, angles, central angles in a circle, and things like that. Anytime you see this symbol theta, okay, this is an angle. Okay, you can think of it as, as shorthand term for the word angle. So you're going to see this a lot, okay? And you're not going to see theta with a degree symbol. You're just going to see theta like this. So one of the main differences between right triangle trigonometry in pre-calculus and in a geometry course is in a geometry course, you may have said this is angle A, angle B, and angle C. And we're still going to have those, okay? But when you talked about angle B, you would have said the measure of angle B is equal to 40 degrees or something like that, right? Okay, in pre-calculus, once we get outside of a basic high school geometry course, okay, we would just call an angle theta, okay, and then we would just give theta the measurement like so. We don't use the m, we don't use the angle symbol. So that's the first thing you need to know about this angle theta. Okay, we can still use capital letters to notate angles like that, but we don't typically put the M and the angle symbol anymore. Okay. The other thing, when we start talking about right triangle trigonometry, if you're in pre-calculus, you've been through geometry, you should be very well steeped in the Pythagorean Theorem, okay, which we all know that a squared plus b squared equals c squared, right? So when we look at this right triangle in particular, a and b are the legs and c is the hypotenuse, right? So if we call this side c, you could call this side a, right? We wouldn't call it side theta, right? Theta is almost always used as an angle, right? Not a side length. And then we could call this side b just for an example, okay? And then reviewing the Pythagorean theorem just real briefly, if we said this is 4 squared plus b squared equals c squared, okay, and we solved for b, we'd have b squared equals 9 and b equals 3, right? So we know that this side length down here is 3, okay? This is, again, another topic for another day, which we'll have a video on this a little bit later. This is one of these magic trios or a triple of whole numbers that form the sides of a right triangle. Now, this is clearly not drawn to scale. These two sides look to be about the same length, but anytime the numbers 3, 4, and 5 are used as lengths for a triangle, that triangle is going to be a right triangle like this, okay? So we'll talk more about Pythagorean triples in a later video. All right, the reason that we're really here is to talk about these trigonometric ratios. Now, the basic trigonometric ratios that you're familiar with, right, are sine, which we abbreviate with an SIN, cosine, which we abbreviate with the COS, and tangent, which we abbreviate with TAN, right? And each one of these ratios, we call them a ratio because what's a ratio? A ratio is a fancy name for a fraction, okay? Now, we're going to eventually get into talking about how these trigonometric ratios are actually functions, right, that need an input. The input to a trigonometric function like so is always an angle, right? So when we talk about the sine of something, it's always the sine of, and we need an angle. So you're going to see theta show up a lot. So the sine of theta, right? And you guys remember this from your geometry course. You know that this is the opposite side over the hypotenuse, right? The hypotenuse. The opposite and adjacent sides, just again, as a quick review, if you're talking about angle theta, and we're putting it down here as this base angle, if you draw a line from the angle into the triangle, the side that you hit over here is always the opposite side, okay? The right angle square that we put in the corner is always pointing at the hypotenuse, which means this other side is the adjacent side, right? And again, I put air quotes around other, but this is our adjacent side down here, Okay, so we have the opposite side, the adjacent side, and the hypotenuse. The sine of any angle is always the ratio of the opposite side over the hypotenuse. Okay, and we're going to build on some of these definitions down the road. If we say, what is the cosine of theta? That is the adjacent side over the hypotenuse, and the tangent of theta is the opposite side over the adjacent side. Okay, so these are our three basic trigonometric ratios, and you'd remember that, the mnemonic device SOHCAHTOA. So you may have been shown SOHCAHTOA like this, right? SOHCAHTOA, like that. I prefer to actually write it like this. Okay, and this is just me to remind myself that, that these are, sorry about that, that these are actually ratios or fractions of sides in a triangle. Okay, so this is your basic right triangle trigonometric ratio review. Okay, again, it's a review. If you have any other questions, you can reach out to me. We can talk about this.